All right, we are continuing Unit 2 with 2.3, Quadratic Equations. In Lesson 1 of this unit, we did linear equations, and I said linear equations were in this form, where the highest exponent was a 1. That's what made it a linear equation. If they are quadratic equations, they will be in this form, where a, b, and c are numbers. And notice this time the highest exponent is a 2. We could actually keep going and naming equations. If the highest exponent is a 3, then it's called a cubic equation. If the highest exponent is a 4, it's called a quartic, and so on. But today, our focus will be quadratic equations. The highest exponent is a 2. One thing that you'll notice in section 1, when we were solving linear equations, the highest exponent was 1, and we got one answer out when we solved it. Today, since the highest exponent is a 2, we will actually get 2 answers out when we solve. So there are different ways to solve quadratic equations, and that is going to be our 4 objectives today, the different ways that can solve quadratic equations. So, a quadratic equation, again, is just what I was mentioning. They will be in this form, ax squared plus bx plus c equals 0. A, b, and c are numbers, and the highest exponent is a 2. One other note you might want to make to yourself, when we solve quadratic equations, there will always be 2 solutions or 2 answers. All right, the first way that you can solve quadratic equations is by factoring. So if we look at this first one, notice how I do want it to be equal to 0, so I want everything on one side, so that's good. If we're going to solve this by factoring, the first thing you should check for is a greatest common factor. Can I take something out of both of these? Well, it looks like I can divide a 2 out, and I can take an x. So I'm going to factor out a 2x, and in parentheses, I'm going to write what would be left. So 4x squared, and I remove a 2x, I would still have a 2x. And now be careful here. My students are always tempted to just leave this back part blank, but there is still going to be a number sitting there. If I had 2x and I divided a 2x out of it, I still have a 1. Okay, once you have factored it, there's multiplication here. What we do is we set each factor equal to 0. And the reason why we can do that, since these factors are multiplied together, there's a property in math that says, hey, if something times something equals 0, then one of those somethings has to be 0. So that's why we can set each of them equal to 0 and solve. So now it's like I have 2 mini equations to solve. This one on the left, if I want to get x alone, I divide by 2. And one of my answers is going to be 0. The other one, if I want to solve for x, I would have to add 1. And then to get x alone, I would divide by 2. So I'm going to leave that as a fraction. So there's my second answer. So my 2 answers are 0 and 1/2. And again, if you wanted to know if you're right, if you substitute those back into the original, we should get 0 out. All right, now the next one, before I factor, I'd like it to be equal to 0. I want everything on one side. So I'm going to bring the 4 over, and to do that, I'm going to have to subtract it over. Okay, once I'm equal to 0, now we're going to solve it. Can I do a GCF? And the answer is no. There's not something that I can take out of all three of them besides one. So if there's three terms, if it's a trinomial, remember when we factored, that's when we called it morphing. So I want to multiply 2 times -4. I want to multiply to -8. I want to add to 7. So I need two numbers that multiply to -8 and add to 7. Should be an 8 and a -1. So now we're going to rewrite it. Remember, when we rewrite it, we just change the middle term, we leave the first and last, and now we're going to group. So from the first group, what could I factor out? Well, I could take a 2x out. And now my goal in this other group is to also see an x plus 4. So what would I factor out? A -1. Since both sets have an x plus 4, I'll factor that out, and then 2x minus 1 is left. And now, since I have my two quantities joined by multiplication, I'll set each piece equal to 0 and solve. So the one on the left to solve, I just have to subtract 4. The one on the right to solve, I'd have to get rid of the 1 first by adding. And then I can divide by 2. So my two answers are -4 and 1/2. Now, the unfortunate thing with factoring is it's not always going to work to solve quadratic equations. There is another way that you can solve quadratic equations, and it's just using square roots. It's going off of the fact, like, if I had something like this, x squared equals 9, well, to cancel out the square, I could just square root, and I would get two answers out. The square root of 9 is 3 and -3, and the reason why, if I were to plug those back into my equation, 3 squared is 9, and hopefully you agree if I did -3 squared, that is also still 9. Two answers. So let's try this. Solve by the square root property. So if I'm using square roots, I would like to get x alone. So if I was solving this first one, I could add 15 over, just like if I was solving a normal equation. And then the next step, I would want to get rid of the 3. And since it's connected by multiplication, I'm going to divide it. And the last step to get x alone, to get rid of the square, I would square root it. That's what undoes a square. So as soon as I take the square root of something, when I physically draw in the square root, don't forget to have plus minus in front of it. The last thing I'd want you to check for is, can we simplify square root 5? Well, thinking of my list of perfect squares, 5 is not a perfect square, so it's going to stay square root 5. So my two answers are square root 5 and negative square root 5. I believe on the homework you will have to enter them separately because there is not a plus minus button. Okay, let's look at the next one. If I want to get x alone, I am going to subtract 25. And then I want to get rid of the 9, and since there's multiplication, I'm going to divide. So I get negative 25 over 9. And now I'm going to get rid of the square root. Oh boy. So I know I'm going to have plus minus. And if this fraction under the square root intimidates you, let's break it up into two pieces, just like we did when we were simplifying square roots. And let's do each separately. So the square root of 25, its perfect square, is 5, but since there's a negative under there, it's going to be 5i. And on the bottom, the square root of 9 is 3. So the two answers, one of them is 5/3 I, and the other one is negative 5/3 I. So these answers are both imaginary answers, but there are still two of them. All right, and the last one. Now, a lot of people will make this last type way more work than it needs to be. Don't write this down, but here's what I'll see people do. They'll write this out twice, and then they'll FOIL it, and then they'll go from there. Now, that will get you to the answer, but it's going to actually make way more work than it needs to be. So we're actually going to take a quicker route. Because this entire left side is squared, what I can do right away is I can square root it to cancel the square. But then I have to do it to the other side. So currently what I have is x minus 2 equals square root 6. And you should be yelling at me right now saying, hey, you forgot something. As soon as you take the square root, plus minus should appear. That's how I'm going to get my two answers. And then the last step to get x alone would be to add 2 over. So I'm going to write it as 2 plus or minus square root 6. I can't actually combine those because they're not like terms, so that's how I'm going to leave it. So my two answers would be 2 plus square root 6 and 2 minus square root 6. If you put that into the calculator, you would get their decimal forms, but I would prefer the exact answer. Then we don't lose any decimals due to rounding. So those are my two answers. All right. The third way to solve quadratic equations is completing the square. This will work all the time for every single one. The only thing is it's kind of a pain in the butt. And this is the type that usually my students struggle the most with. So let's just jump right in. To complete the square, I always think of this method as we are trying to make the polynomial or the quadratic equation, we're trying to make it perfect. So we'll go through the steps here. You don't have to worry about step 1. We're not going to mess with that. So step 2, which is going to be our step 1, we are going to move the c term on one side by itself. And when I say c term, I'm referring to if we're in the form ax squared plus bx plus c equals 0. So when I say the c term, I mean like the constant, the one without any variables. We're going to move that over. Okay, step 3 is where completing the square comes into play. So what we're going to do is we're going to take the b term, whatever is sitting in b spot, and we're going to divide by 2, and we're going to square it. And this number we're going to add to both sides. Now if you're getting overwhelmed by this, I promise once I show you with numbers, you'll see why we're doing this. And then finally, step 4, we already know how to do. To finish it, we will factor and use square roots to finish solving. So let's try it because it doesn't really make sense until we have numbers thrown into the mix. Solve this equation by completing the square. So what I'm going to do is I'm going to take the constant term, the c term, and I'm going to move it to the other side. To move it to the other side, I would have to subtract 4. Okay, so that's the first step. The next step, I want you to focus on the b term, which is sitting in front of x. We are going to divide that by 2, which is -3, and then we're going to square it, which is 9. This is where the name completing the square comes from. So I took b divided by 2, and then I squared it. So what we're going to do with that is we're going to take our polynomial, our quadratic equation, and that number that I came up with, I'm going to add it in. Now in the math world, this is a horrible math sin. I can't just add something to one side magically. So to keep it balanced, if I added it to one side, I do have to also add it to the other side. Just like when we solve, you do it to one, you do it to the other. The whole reason why we just did that, why we went through all that work, is if you have completed the square correctly, this left side will now factor. So let's see. I want to multiply to 9, and I want to add to -6. So what two numbers do that? -3 and -3. If you have completed the square correctly, when you go through this factoring, these two numbers will always be the exact same. If they're not the exact same, you have done something wrong. That's what I mean when I say we're making it perfect. It will come out nice and neat and perfect. So let's factor it. So x minus 3 and x minus 3. On the other side, I can combine like terms. -4 plus 9 is 5. And now in the math world, when we did the factoring unit, I said, hey, if you factor something and it looks exactly the same, we can actually just write it once with a square. And now if you think about that last example we did on the square root ones, if I want to finish solving this, since the entire left side is squared, I can square root the whole side. If I do that to the left, I do it to the right. I'll come up here with my work. So on the left, I now have just x minus 3. And on the right, I have square root 5. And hopefully you're yelling at me, since we took the square root, plus minus appears. And there's one step left. I'm going to add 3 over. So I would get 3 plus or minus square root 5. So separately, my answers would be 3 plus square root 5 and 3 minus square root 5. Again, if you type those into the calculator, you'll get their decimal forms, but we'll leave them exact like those two answers. Okay, I want to try another one just to make sure we have completing the square down. So notice on this one, the c term is already on its own side, which is great. So we'll skip over that first step. So now we're going to complete the square. So we're going to look at b. We're going to divide by 2, which is 2. And then we're going to square it. That's why it's called completing the square. So I get 4. So now what do I do with that number? I take my quadratic, and I'm going to add that number in that I just found. And on the right side, if I add it to one side, I have to add it to the other side to keep it balanced. Now, the whole reason why we just completed the square is if you've done it correctly, the left side should now factor. So I want to multiply to 4, and I want to add to 4. What two numbers do that? 2 and 2. And remember I said if you've completed the square correctly, when it factors, you should get the exact same number. So it's going to be x plus 2 and x plus 2. On the right side, I now have 16. Since they factored into the exact same set, I can write it once using a squared. And now we want to solve from here. So to solve for x, I will square root both sides. Now on this one's nice because the square root of 16, that's a perfect square. It's just 4. Hopefully you're yelling at me because when we square root, we'll have plus minus. And the last step, I want to subtract 2 over. So I get negative 2 plus minus 4. And now I'm going to write my two answers out separately. So negative 2 plus 4 and negative 2 minus 4. Now here I would actually, you can tell me what those are because there's no square roots. So negative 2 plus 4, I get a nice whole number answer, 2. And the other one, negative 2 minus 4, I get negative 6. So those are my two answers. The last method for solving quadratic equations is also a method that will work every single time. Now, I have some students in the past who have not liked factoring, and they said, hey, can I just use the quadratic formula to solve? And I go, sure. So it is a formula, and this is a formula I will expect you to know. It's one of the few formulas that I do make my students memorize. Usually I just give formulas because I'm not a big fan of memorizing formulas, but this one is a big deal and it gets used quite a bit. So if my quadratic is in this form, just like what we've been dealing with, the quadratic formula gives us a way to solve. I'm going to write it up here. So if I want to solve for x, the quadratic formula says negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. This formula often looks super intimidating to people, but if you can plug a, b, and c in, it's actually not that bad to work with. And okay, I have to do this. It always makes my students cringe, but there is a song that goes with this that might help you remember it. Pardon my singing voice. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. I don't know if that will help you, or maybe you're traumatized now, but it has helped my students in previous years. So let's try it. Solve by using the quadratic formula. Off to the side, it might be helpful to identify our 3 values before we use the formula. And again, how you know what a, b, and c are, it's in this setup. So a is with the x squared, so a is 8, b is with the x, and c is the constant, negative 1. So we're going to substitute in. So notice in my formula, it's a negative b, so b is 2, it's going to become negative 2. Plus minus the square root of b squared minus 4 times 8 times negative 1, all divided by 2 times 8. So I'm just substituting in for a, b, and c. Now we're just going to simplify it. So negative 2 plus or minus 2 squared, order of operations, right? We do the exponents first, 4. And back here, let's do all of our multiplying. So negative 4 times 8 is negative 32 times negative 1 is 32. So this really becomes plus 32 all over 16. So then I get negative 2 plus or minus the square root of 36 over 16. And then I always ask my students to check if that square root will simplify, which it does. 36 is one of our perfect squares, so it turns into 6. And the last thing that we can do, because I can do it from all 3 numbers, we're going to divide something out. What can I divide from all three numbers? Should be a 2. So if I do that, I'd have negative 1 plus or minus 3 over 8. I divide everything by 2. So if I write my two answers separately, negative 1 plus 3 over 8 and negative 1 minus 3 over 8, we can actually finish this because there's no square roots. So negative 1 plus 3 is 2 over 8. But I'd like that fraction simplified. So there's one of my answers, 1 over 4. And if I do the other one, negative 1 minus 3 is negative 4 over 8. And simplify, my other answer is negative 1/2. So notice I still get two answers. All right, let's try another one. So A, B, C, 2, negative 6, 1. Oh, what's that you said? You forgot the quadratic formula? Well, let me just sing it for you. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Sorry, not sorry. All right, so let's substitute in. So now careful here. I have negative b, but b is negative 6. So it turns opposite, because I'd have a negative 6 plus minus. Parentheses are super important here when we square this. Minus 4 times 2 times 1, all divided by 2 times 2. Okay, so now we just have to simplify it. So 6 plus or minus negative 6 squared should be a positive 36. Make sure that negative gets included. Positive 36. And then negative 4 times 2 times 1 would be a minus 8. All over 4. 36 minus 8 would be 28. And then I'd like you to see, can the square root be simplified? Yes, it can. 28 is not a perfect square, but there's a perfect square in it. I could think of that as 4 and 7, because 4 is a perfect square. So it would become 2 square root 7 all over 4. And the last thing that you could do, because I can do it from all three numbers, I'm going to divide 2. So I get 3 plus or minus 1 square root 7 over 2. So my two answers would be 3 plus square root 7 over 2 and 3 minus square root 7 over 2. I can't do any more simplifying besides turning them into decimals. So that's how I'm going to have to leave my two answers. Not the prettiest things. These are irrational answers. One more, just because I want to make sure we have this formula down. So 3, negative 2, 4. Oh, gosh darn it, you forgot the formula again. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. I promise there's a method to my madness. Just think, you only have to put up with me for a semester. My students get me the whole year, those poor souls. So if we substitute in negative b, so b is negative 2, it's going to turn opposite. And then b squared okay, so I'm just substituting in for a, b, and c. And now let's simplify it. So negative 2 squared would would be a positive 4. And then I want to do my multiplying on the back end. Negative 4 times 3 times 4 should get negative 48 over 6. So 2 plus or minus, I get a negative 44 under the square root when I subtract. Okay, and now I'd like you to simplify the square root. 44 is not a perfect square, but there is a perfect square in it. If I think of it as negative 4 and 11, so that would simplify. Square root of 4 is 2, but because of that negative under the square root, I'm going to have I up here. And finally, because I can do it from all 3 items, I would like you to divide a 2. So when I do that, 2 divided by 2, you have to have a 1 there, plus minus 1i square root 11 over 3. So my two answers would be 1 plus I square root 11 over 3 and 1 minus I square root 11 over 3. So 2 imaginary answers. All right, let's end with a story problem or an application here. Quadratics appear a lot in physics, especially with motion. Whenever something is tossed or thrown or fired into the air, you're dealing with quadratic equations. So in this example, a person's normal systolic, I think I said that right, blood pressure measured in millimeters of mercury depends on his or her age. The formula, and then it gives me this quadratic equation. I know it's quadratic because the highest exponent is 2. Models a man's normal systolic pressure, P, at the age of A. Find the age to the nearest year of a man whose normal systolic blood pressure is 125. All right, so the question is, they've given me a value and they want me to find the age. So the first question I ask my students is, what would we substitute the 125 in for? And you should say we're going to put it in for P because it's the pressure. So if I substitute in 125 equals now it wants me to solve for A. I want to figure out the age. So we have some options to solve this quadratic equation. We could try factoring, square rooting, completing the square, or the quadratic formula. Those are my options. In my opinion, the route that would probably be the easiest is the quadratic formula. In order to use the quadratic formula, I do need to be equal to 0. So this 125 has to move over. So I'd have to subtract it over. And let's quick identify A, B, and C. Make sure B is negative, and make sure C is negative. Oh, you forgot the formula? Well, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And technically, picky detail, we're not actually dealing with x, we're dealing with capital A. That's my variable that I'm solving for. So let's substitute in. All right, oofda, lots of decimals here. So if we start simplifying, I'll tell you, if you simplify under the square root correctly, the number that you should get at the end is 0.1204 after combining everything. And on the bottom, we should have 0.012. So I would try this in your calculator, see if you can get these decimals. And since this is a story problem, when I write my two answers here, I can't really do much with that square root. Okay, there's my two answers. I actually want you to put this into the calculator and this time give me the decimal answer. Because these formats by themselves don't make sense in this situation. I want an age out. And if you ask someone, oh, how old are you? They wouldn't say, oh, well, I'm 0.02 plus square root, blah, 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 years old. That wouldn't make sense. So let's actually type these into your calculator. So take 0.02 plus the square root of that decimal, and then divide by 0.012. And I want to know what comes out. So I think with rounding to the whole number, because I think they did say to round to the nearest year, this one should come out to 31 if you enter it correctly. And the other one, if you do 0.02 minus the square root of that decimal, all divided by 0.012, you get negative 27. So think about it. In this story problem, which one of these does not make sense? The negative one. So I'm actually going to throw that answer out. So our answer would be 31 years old. That is the age of this person. So usually on the application ones, there's going to be one answer that doesn't make sense.